In this example, we're going to use the given sign charts for f, f prime, and f double prime to construct a combined number line and then use that combined number line to get a good sketch of a possible graph for the original function f. So the piece of information that f is giving us is whether we are looking at above or below the x-axis. F prime is giving us increasing and decreasing, and F double prime is giving us concave up, concave down. And of course, there are important points that are associated with each of these functions as well. And so what we do is we take all of the different values that we see on any number line at all. So we see a -1, a 0, and a 1 on the different number lines. So if it lands on any of the number lines, it needs to land in our combined number line here. And so what we start with is using the plus and minus for f to determine whether we are above or below the x-axis. And then we're going to use that information to give us a good visual. So the visual that we're going to get is everywhere that we have a plus, we're going to have a box that is above the x-axis, or above the combined number line here, giving us a visual for above the x-axis. So we see a plus on the interval -∞ to -1, so we have that box there, that rectangle, landing in that interval above the combined number line. But then we have that f is negative from there on out, and so we're going to have our rectangles for each of the remaining 3 intervals be below the combined number line, indicating that our function is going to be dropping below the x-axis there, and will stay below the x-axis there. So those boxes are really giving us the information we need about read off from f. The one other thing that we know from this is that at -1 we have a 0. It does cross the x-axis there. It touches the x-axis there. So now we move on to the first derivative. Now the first derivative is giving us information about increasing and decreasing, but what we're going to do is we're going to combine that with our second derivative information. So each one of these rectangles needs a sign for the first derivative followed by a sign for the second derivative. So I'm just going to work through the first derivative first. We have from -∞ all the way up to 0, the first derivative is negative. So in this first slot here, for both of the intervals -∞ to -1, as well as -1 to 0, we have negative for the first derivative. Then the first derivative is positive between 0 and 1, and so in that first slot for our rectangle, we put positive there, indicating our first derivative is positive. And then from 1 to infinity, for the rest there, our first derivative is negative, so that first slot in the rectangle is negative for negative first derivative. Moving into the second derivative, we see that we have the second derivative is positive all the way up until 1. And so we just put in positive signs here for each one of the first 3 rectangles, indicating our second derivative is positive. And then once we pass over the 1, our second derivative is negative. And so our second slot there in that final rectangle is negative. So what we're going to do is we are going to have these combinations of signs for first and second derivative give us our arcs. So our negative-positive combination is negative first derivative, positive second. So that would be decreasing but concave up. So decreasing means we're going down but in a concave up way. And that same sort of arc happens here in the next 1, 2, between -1 and 0. We are decreasing but in a concave up way. Now between 0 and 1, we switch to positive. So the first positive is indicating increasing. The second positive is indicating concave up. So we are going up in a concave up way. And so we've got an arc that looks something like that. But then it switches to negative, looking once we hit 1. The first negative is indicating that we're going down. Second negative is indicating that we're doing that in a concave down sort of way. And so there's the arc that we would see. So now the thing that we overlooked here was what was happening at 0 and 1 as far as the first and second derivative goes. We see that we at 0 go from down to up, so we do in fact see the min that we expect at 0 there as we've thrown in our arcs. Now we know that that at 1 the first derivative does not exist, but it's in the domain of the original function. So since we're going up followed by down, even though it doesn't exist, it's going to be a max. And we do see that max is happening there because it is in the domain of the original function. But the other thing that we notice is the derivative does in fact not exist there, because we're going to have some sort of kind of semi-cusp happening. A sharp turn is happening there due to the two different arcs being pieced together. There's going to be a sharp turn there. Looking at the second derivative there, that special point of 1, said that the second derivative did not exist, but that 1 is in fact in the domain still, and so not only is it going to be a max, it's going to be an inflection point because we switch from concave up to concave down there. It happens to be at a max because that's a particular place there where we have a somewhat of a cusp looking thing. So now that we have done our combined number line and we've somewhat annotated it nicely, the graph at this point then becomes fairly easy. We know that we have a 0 at -1, so we'll go ahead and mark that. We see a min there at 0, so we need to make sure that we stay below the x-axis throughout all of the right-hand side. Starting at -1, we've got to stay below the x-axis. But we also see that we've got to have that sort of sharp turn that's happening at 1 there. That is a max, but it's also a change in concavity. Now, looking at what's happening at -1, we have this same sort of decreasing concave up arc on both the left and the right of -1. So the only really important thing that's happening there at -1 is our graph is crossing the x-axis. And so really we do still have this sort of smooth continuous function there. It's just the important thing that happened is it crossed the x-axis. And so we've got this big concave up arc that then switches to concave down at -1 at that sharp turn, or at +1 at that sharp turn. And we had to make sure we paid attention to where we were both above and below the x-axis throughout this whole example.